Here we have a question that's asking us for the temperature that a 0.58 liter balloon must get to in order to expand to 2.50 liter if its initial temperature is 25 degrees Celsius. So let's list out all the information that we're given: 0.58 liter, 2.50 liter, and 25 degrees Celsius. So we have two volumes and one temperature. And then we're asked to find the temperature, which is T. Now let's read through the question once again to figure out which one is V1, V2, T1, T2. So it's asking us for the temperature that a 0.58 liter balloon must get in order to expand to 2.5 liter. So that expand tells us that 2.5 liter is the new volume, which is V2. So 0.58 liter is going to be V1. And then after that, it tells us that the initial temperature is 25 degrees Celsius. So that means T1 is 25 degrees Celsius, which means the temperature that we need to find is T2. That's how we tag the information that we have. Now that we have tagged all the information, we're ready to solve the question. So we first need to identify the gas law. Notice that we are only dealing with volumes and temperature changing. There's no mention on the moles of the gas, and there's no mention on the pressure. So we just assume they remain constant. So that means we need a gas law that deals with volume and temperature, and that's Charles' law. V1 over T1 equals V2 over T2. Now the temperature that we're given is in degrees Celsius. So we need to first convert it into Kelvin. So to convert the temperature, we add 273.15 and that gives us 298.15 for T1. Now we can plug it in. Now the question asks us to find T2. So let's rearrange the formula a little bit so that we can solve for T2. We cross multiply. So V1 multiplied with T2 and that's equals V2 multiplied with T1. Now we're closer to solving for T2. Now all we have to do is isolate T2 on the left hand side. So we do that by dividing with V1 on both sides of the equation. That way we can get rid of V1 on the left hand side. So that's going to leave us with T2 equals V2 times T1 over V1. And now all we have to do is basically plug in all the information that we have tagged nicely into this new formula. And that gives us 2.50 liter times 298.15 Kelvin divided by 0.58 liter. And that solves out to be 1285 and round off to 1300 Kelvin in 2 sig fig. With that, we're done solving this problem. Here are the two videos that I've handpicked for you. Thanks for watching all the way till the end. If you find this video helpful, be sure to like and share it with someone. Don't forget to subscribe. Your support means a lot to me.